So in this lesson, we will hand trace a reasoning loop. There will be no zip file for this lesson. We will be running the BigQuery agent that we built previously, and we'll be inspecting its trace, so there's nothing new to download. If you don't have that project handy, go back to the earlier lesson where we built it and work through that one first. Now, just a quick introduction, like usual. What is this lesson and what is the importance of the reasoning loop? Well, in the last lesson, we built an agent and we watched it answer a question, right? We asked about Stack Overflow data and it figured out, which tables to look at, which project to build the query to, wrote the SQL query, ran it, and answered our question. And from the chat panel, it was pretty smooth. But what actually happens under the hood when an agent uses tools to answer a user's question? What actually happened in there? The agent, made multiple decisions in a row or multiple tool calls in a row. It picked a tool, looked at the result, picked another tool, looked at the result, and it kept going. It was, I think, 3 tool calls until it was ready to answer, right? And every one of those decisions was a separate trip to the model. And every one of those decisions can be inspected, especially in the ADK Web UI. So you must recognize that at some point you will need to understand that at a more detailed level. You will need to open the trace and look at the events and really understand the loop. So this loop is about how to read what your agent actually did. Not the bubbles in the chat panel, which give you the rough shape, not just what the agent responds to you with, but the full reasoning loop, right? Look at what the model saw, what it decided, what it came back with, and what it decided next. So you need this skill in order to actually debug and improve the performance of your agent and make sure that it's doing under the hood what you want it to. Okay, so what do we mean by reasoning loop? Let's just review this. The reasoning loop is the LLM continuously calling tools, looking at the responses of those tools, and then calling more tools until it decides that it has enough information to write an answer to the user. So we've talked before about the fact that an agent is just an LLM plus tools in a loop. So the model takes in everything that it knows so far with each of the loops. It takes in the user's message. It takes in the system instruction. It takes in the descriptions of the tools that it has available to it. It takes in the conversation history so far. It takes in the results of the tools that it has seen, the function calls, the tool calls that it has made already. And then it decides to either make another function call, so then the loop continues, or it gives a text response to the user, right? So let's get a little bit more precise. A single thought, right, from the LLM is one round trip to the LLM, right? The ADK calls this a call LLM span, and you'll see that in the trace when we look at the ADK Web UI. It was also in the previous lesson, but we didn't really point it out particularly. So the model takes in everything it knows, as we said, and then it either executes a tool, which again is what we would see in the actual ADK, or if it does this enough times and it is happy with the response from the tools, it has enough information to answer the user, then it will decide to output text to the user rather than a tool call, right? So here we have 1, 2 tool calls, and then the text is output to the user. But really, this could be 1 tool call. It could be 0 tool calls if the LLM has enough information without calling a tool to answer the user. Or this could be many. I mean, this could be 5, 10, 20 tool calls. Of course, you don't want your LLM to call too many tools because each one costs tokens. But this is kind of a simplified version of what every loop is. The LLM decides which tools to call, and it continues to do that until it has enough information to answer the user's question. So this is the engine inside the ADK. Every agent works this way. The reasoning loop is what turns an LLM into an agent and what makes it feel to you like the LLM is autonomous and making decisions and exhibiting more intelligence than an LLM that is not an agent. It's really just that it has access to these tools and it gets to keep calling the tools until it has enough information to answer the user. All right. So what we're going to do, we're going to take the agent that we built previously, which is the BigQuery agent, with the custom tool that we built to get the GCP project information and the BigQuery toolset class that we included. And we're going to basically kind of put it through its paces, or at least try to, which will look a little bit different each time, including different from the previous times that I ran this, because LLMs are non-deterministic. So note that the results that I may get may not be exactly the same as what you get. But we're going to ask it some questions, that are maybe intentionally hard. And then we will look at the traces view, and we'll walk through the loop step by step. We'll look at the events in the ADK web to really understand what's going on. So hopefully we will be able to make it encounter an error, and we will see what it does, because I think that will be informative. But we never really know until we actually try, because the LLMs are, again, non-deterministic. So there's no new code to write in this lesson. We're using the same project, the same agent. We are learning to read what is already there. Right? The point of this is to just learn how to read the activity of your agent in the ADK web. Okay, so let's go over to Cloud Shell, and I'm just going to refresh this. It's going to take a second to load. I'm going to set my project, gcloud config set project. And again, this is my project, but yours will be different. And then we want to see our BigQuery agent again. So you can type in this command, Cloud Shell Open Workspace BigQuery Agent Project, and it should pop up. This is what we were working on in the last lesson. Now, again, we're not writing any new code, right? This is everything that we did last time. We're just going to run the dev UI. Now you can click on the address that it's running at. This should look familiar to you. Click on BQ agent, which corresponds to the subdirectory that our agent is in. And so now we're going to start asking it some questions, right? So let's ask, what are the top 5 most viewed Python questions on Stack Overflow this year? And the reason I'm asking it this question is because it really should not be able to answer this question because the Stack Overflow data set actually does not include this year. It only goes up to, I think, 2022 or 2023. So I want to see with you what the agent does. So it's thinking. So this is actually interesting because in the last query that we ran in the last session, we actually saw that the agent was able to use the get GCP project info tool in order to query the Stack Overflow data. It recognized that it wasn't able to query the data in the BigQuery public data project, which is exactly what happened again in this situation. But instead of trying to get the project ID by using the get GCP project info tool, it just says that it's unable to retrieve the 5 most viewed Python questions. So this actually speaks to the non-determinism of LLM agents. So what I'm going to do actually is I'm going to try to make this a little bit more predictable. And I did not prepare this. I did not do this before. So we're going to kind of do this on the spot here. So you are a helpful assistant with access to information about the user's GCP project and access to BigQuery. You can answer questions about the user's project, query BigQuery datasets they have access to, and explore public datasets like BigQuery public data, Stack Overflow. Yeah, so when the user asks a question about that requires data, use BigQuery to find the answer. And so I am going to add something here that says, let's see, keep in mind that the BigQuery public data project is not actually the project you would run the query in, even though it's the project where it is the project where the data resides. Okay, so now let's save that and let's run it again. Now the reason I'm doing this is I'm kind of nudging the agent to recognize, okay, that the BigQuery public data project is where the data is. And so I do want to reference that in my query, in my SQL query, but it's not necessarily the project ID that I should specify. BigQuery public data is not necessarily the project ID that I should specify as the project where the query is run, where the compute is actually used to access the data, right? So let's see if this helps. So let's ask the same thing. What are the top 5 most viewed Python questions on Stack Overflow this year? Okay, so this was actually much more informative, or more along the lines of what I would have expected, right? So here we see the Get My GCP Project Info tool was called, and what we got in return was the project ID, display name of the project, the creation time of the project, and the state of the project. And then it was able to use that project ID to actually execute the SQL. If we look at the trace here, we'll also see some interesting things. Actually, first, let's go through the events again as kind of a summary. It called the Get My GCP Project Info tool to find the billing project. It ran a SQL query against the BigQuery public data Stack Overflow .post questions table after getting the billing project. You can see that here. So BigQuery public data Stack Overflow .post questions, including the project ID that it grabbed from the previous tool call, Agent Platform GCP Study Hub. Yours, again, will be different. And it got back, it got back an empty result. Okay, so the status was success because the query did run, but there are no rows that were returned. And that's because no data was found. And so it says, I couldn't find any Python questions for this year in the Stack Overflow public dataset. This might be due to the dataset not being fully updated for the current year yet. Would you like me to look for the top 5 most viewed Python questions of all time instead? Okay, so we can understand the actual reasoning loop by looking at the greater detail on the left here. And now zooming in a bit on the trace, we can also see some useful detail. The total latency here was 12.03 seconds. We can also see how much of that was comprised of each of the individual steps of the reasoning loop. So at the top, we have our invocation ID, which is a long hash that uniquely identifies this turn We have the total latency for the invocation. And then underneath that, a tree of spans, right? And so we've got 3 call LLM spans, 1, 2, 3. We've got 2 spans nested inside the first 2 of them, generate content and get my GCP project info for the first one, generate content and execute SQL for the second one. And so this alternating pattern is the reasoning loop, basically. So every call LLM is one model decision. The tool span nested inside of it is what the model decided to run as a result. And the last call LLM has no tool span because that is where the model produced its final text answer. And you can see that as I hover over it, right? You can also see that the generate content spans correspond to the lightning bubbles that we see in the chat as I hover over them. Now, notice the duration bars here as well. The call LLM spans are the slow ones, generally, because the model is quote unquote thinking, sometimes for multiple seconds. And then the tool spans are faster, right? Because tools are basically Python code running or API calls. So we would kind of expect them to be faster. LLMs may get faster, over time, but you can see a pretty significant difference between how much of the total latency was taken up by the LLM versus the tool calls. And going back to the events view, I want to show you something else useful. If we click on one of the lightning bubbles, okay, and we click on the request button on the left here, we can actually see exactly the data that the model received before making its first tool call. So we can see the system instruction, which includes the information that we added. And we can see the function declarations, which include the descriptions of the BigQuery tools. All right. So this is the kind of debugging that you would want to do as you are building your agents. So just a few things to take away from this trace, right? So the events view here showed you the tool call chips, which gave you, the rough shape of what happened. The traces view gives you the actual sequence with their model decisions, tool executions, and timings of each part of the loop and the total latency. And when the model has quote unquote memory, right, the memory within a single invocation is just the full conversation history, including all of the prior tool calls and their results. So if we click on execute SQL, we would see again all of the system instructions, the descriptions of the functions and tools that it has available to it, and we would see the result of the previous tool calls. So let's see if I do agent platform. Yeah, so down here is the project ID, display name, creation time, that was added to the data that was sent to the LLM as a result of the previous tool call, which we saw here, right? And if we click on this one and go to the request tab, we would not see that. I hit Command F and am hitting enter, and it's not showing up anywhere. So this just had the system instructions, the user query, the tool descriptions, and then it grabbed the project ID, and we can see that that was passed in down at the bottom. Okay, so you can really understand what data, including the tool descriptions, the results of the tool calls, the system instructions, etc., the user queries, the conversation history, what was actually sent to the LLM at each pass. All right, so now I ran a few more queries to try to get some interesting results that we can look at together. So I ran this query, what's in my private dataset.users table, which is just a made up table name. And you can see here that the agent, again, called get my GCP project info. And then it got the project ID and it tried to find that data set, and it got an error in response. Okay, so we get a 404 that the table does not exist. The data set does not exist. So then it described that back to me. It seems that the data set was not found, etc. I also asked it to drop a table, and it says immediately, I cannot fulfill this request. You do not have the necessary permissions to drop tables from BigQuery public data. This project contains public data sets and is read-only for users. So it actually didn't even make any tool calls. And the model actually refused this without even, trying, without even making any tool calls. So that tells me that actually it knew to refuse this request even without resorting to the fact that the BigQuery toolset has write access blocked. And I would want to investigate that. In fact, I probably could run a similar query. Yeah, okay, so it says, I just asked it, delete all data sets in Agent Platform GCP.hub project. I'm sorry, I cannot fulfill this request. I do not have the functionality to delete data sets. I can only list information about them or query them. And so what I am inferring from this is that actually what it did was it looked, so this is actually interesting, a real good teaching moment. So it looked at if I click on the response from the agent, I can see that it was sent all of the system instructions and the descriptions of all of the tools. And it ascertained from the descriptions, it must have ascertained from the descriptions of the tools that it only has the ability to list information about them and query them, not write to BigQuery or delete. So I read through the request that was actually sent to the model, and what you don't see is write blocked mentioned. And so that means it actually did not decide that it can't fulfill the request based on that. But what it probably did, and again, this is me figuring this out on the spot, just as I think you should do if you are working with agents in the ADK. So what I think happened is it read the descriptions of the BigQuery tools, which all included, getting dataset info. Let's see, we've got get dataset info, right? There's also one that's list dataset IDs. And so it looked at all of the functions and looked at what it can do with those tools and noticed that deleting tables or datasets is not included. And so that's why it decided that it can't fulfill the request. So again, this kind of thing is really useful. Let me just touch on a couple of other queries that we ran. So I asked, compare the row count of BigQuery public data to Stack Overflow post questions to GitHub repos .commits and tell me which is bigger. So we can see the entire request. We can see the response. And so the request was just selecting the count. That was the query. We can see the response, which is the number of the number of rows in that data set. And then it did the same thing for the GitHub repos and returned the number of rows and then gave a natural language response. And so we could see the trace for that too. If we go down here, right? So this was the natural language response. These were where it executed the SQL. So I could look at it from that perspective too. And then if I go back to, this one's kind of interesting. What tables in the Stack Overflow dataset have a creation date column? So when I ran this, it had to go through all of the tables. So what it first did was it listed the table IDs. Okay. So it ran the list table IDs tool and got all of the table IDs, badges, comments, post history, post links, etc. And then it started going through each of those tables and getting the information about the tables, including the columns. So it kept doing that for each one. Now, it kept doing that, and I ran into a quota error. So I actually did not get a response from the agent, but that's an API like rate limiting thing from Gemini. That's not an ADK issue. So this would have kept going if I had a higher quota. But it kept going through all of the tables because I asked what tables have it. So, even if it found the column in some tables, it really needed to check all of them. And so this is something I was able to, figure out. I was able to figure out how exactly the reasoning loop worked for this because I knew to look at the information and the request information on the left panel. Okay, so I think you kind of get the point, and now it's time to summarize the lesson. So just some things to kind of think about as you build agents. When something looks weird, right, you should open the trace and the event detail in the ADK web. And actually, you should really do this in general, even when you're not getting weird results, because you want to make sure that your agent is doing what you think it's doing, right? Obviously, you don't have to do that for literally every response, but I think it's a good habit to get into. The events view shows each step as a chip that you can click into, and the traces view shows the loop's shape and timings. So, different questions kind of get answered by different views, but it will save you a lot of guessing. So the events view and the traces view, right? Additionally, you should note that errors are just part of the loop and they can actually be informative for the model. So we saw a couple of errors here. We saw that the agent, it's still like the loop still completed. The error was informative for the agent and the agent responded based on the error. Now, I don't think we had a loop where the error happened and then the agent continued to try new things in order to not get an error. And that has happened to me before. That happened when I ran this on my own earlier, actually. But the point is that regardless, errors are not necessarily bad things. Like, it is the agent learning about its environment, right? Third, you should look at what the model saw before each decision. That can be very informative. So clicking on a model response chip in the events view, and then clicking on the request icon, right? So that was this. We can see what the model actually saw. And we can see that if we click on any of the Lightning chips as well. So this is kind of underused, I think, as a debugging tool in the ADK. It gives you can really picture what the LLM is being told before each request. And if your agent calls the wrong tool or hallucinates an answer, the request view, can be really helpful because it tells you what the agent was working with. Slow call LLM spans usually mean that the model had a lot to read. We expect these to be generally slower than tool execution anyway, but if they're particularly slow, that can mean that the model had a lot to read. And, having multiple iterations is normal, right? I mean, we saw multiple examples of the agent calling multiple tools And that's kind of the entire point of agents. But you should watch out for inefficiencies and wasting tokens. If you're getting a lot of loops with your agents, then maybe there's a better way to structure the descriptions of the tools or the system instructions so that the agent has more guidance without confining it too much. All right, that's it for this lesson.